Hey guys, today we're going to be talking about medians and centroid and also altitudes and orthocenter. So let's go on with this. A median, if you remember, starts at a vertex and goes to the opposite side at the midpoint of the opposite side of a triangle. So you have two congruent sides, two congruent segments on the opposite side. It joins the vertex of a triangle to the midpoint of the opposite side. When three medians, that's what a median is, okay? When three medians intersect, you have a centroid. And there's some useful information to know about a centroid. First of all, let's go ahead and name our median. So from the vertex to the opposite side, we have CD, we have BF, and we have AE. Oops, that didn't mean to use the same color, but that's okay. All right, so we have three medians. The orthocenter is where they intersect. So the centroid, oh my goodness, so sorry, the centroid is P. All right, what special properties exist for a median? So here's where it's going to get a little confusing, but try to stay with me. So let's look at AE right here. This is the one I'm going to bring over here. If we have AE, and right there at P is where the centroid is, then you're going to notice if I put another little line right here, you can essentially break up that median into three parts. So from the segment to the centroid is one part, and then from the vertex to the centroid is two parts. Okay, so I'm just going to break them up in 1:1. So it's a 2-to-1 ratio. So keep that in mind as we discuss these things. So for example, PE, the smaller part, PE right here, compared to the entire thing is 1/3. All right, so PE, just the small section from the centroid to the segment, is 1/3 of the entire median. So that's AE. All right, where conversely, what we were just saying is the larger portion, AP. AP makes up 2/3 of the entire median. So AP, from the vertex to the centroid, makes up 2/3 of the entire median. And then more specifically, if they're giving you a measure, let's say of the AP, then you're going to know that the EP portion or the PE portion is 1/2 of that. So that's probably where you're going to use the information more often. So AP, let me just write it down here. This larger part equals 2 of the smaller parts. And the smaller part equals 1/2. So if they give you the measure of AP, you can know that 1/2 of that measure is going to be the PE. All right, so let's practice that. Let's go right here to number 2 because I feel like you know how to. Remember, a median makes a midpoint, so you know that part's going to be congruent with each other, that part's congruent with each other, and that part's congruent. That's how you do number 1. If we look at number 2, it's saying if Z is the centroid of triangle TUV, TZ is 60. So right here, TZ is 60. So you already know that that's two parts. One part of that means that this is going to be 30. All right. XZ is 28. Let's do a different color for that. XZ is 28. And WZ is 25. 25. Okay, so you just got to know that they gave you all this. They gave you one larger portion, and they've given you the smaller portion for those. Find each missing measure. So we need ZV first. ZV. ZV is the bigger portion to this 28. So let's just divide it up in thirds. They gave us 28. We know that they're all 28 segments, so we need this portion for our ZV, sorry, ZV. So 28 and 28 is going to be 56. Okay, the next one they're giving us is ZY. They want us to find ZY. Well, I already found that for us earlier. That's 30. How did I do that again? Well, they gave us the 60. If we divide that in half, we have the smaller portion, which is 30. All right, the next one they're giving us is they're asking for is ZU. That's the larger portion of this. So 25 times 2. 25 times 2 because we said the basically we know that ZU is going to equal 2 of WZs. So ZU is going to equal 2 times 25. So ZU is going to be 50. All right, if you didn't want to do it all algebraically and you just want to draw yourself a picture again, the entire median is called WU. The entire median is called UW, basically, if we start at the vertex, okay, UW. They want to know, well, what is the measure of ZU? They gave us 25 for, I'm writing it all backwards, I'm so sorry. This is where the Z is. Okay, they gave us 25. So we know that this is also 25, so this portion is going to be 50. Okay, let's look at another one. Let's try number 4. All right, if the centroid is X, then we know that these are congruent. We know these are congruent. We know these are congruent. They want to know what TX is. TX is located right here. It's the larger portion of TU. TU. And they want TX. Did they give us anything about TU? They gave us that the whole thing is 27. So if we divide that whole thing up, it's all 9s. 27 divided by 3 is 9. So if they want just TX, that's going to be 2 of the 9s, so 18. Next thing, let's go ahead and fill in what they gave us. They gave us that SW is 18, so the whole measure is 18. And they want to know what XU is. So that's not related. SX, they want to know what SX is right here. Okay, well, 2/3 of 18, we can say 2/3 times 18 is going to give us that amount. So that's going to be 12. All right, let's make our segment again. SW is 18. If we divide that up in 3 parts, that's going to be a 6, and a 6. 2/3 of that will give us the 12. All right, let's try one more. It's saying XU. Give me XU, and what did they give us? RV is 21. So the entire median is 21. If we divide that up in thirds, it's going to be a 7, a 7, and a 7. And they want just the X. I keep using the wrong information for the wrong thing. What did they even give us for this one? XU. Okay, I figured out what I was doing here. Okay, so we need to look at this measurement right here. Okay, earlier we already knew that TX was, we knew TU was 27, this blue marking. We knew TU was 27. We already did the work right here. We divided it up in all 9s. So if they want to know just the TU portion, the XU portion, that was a 9. All right, let's try number 5 so we can work with some algebra here. It's saying that J is the centroid. All right, and the median that they're talking about is EI. Okay, so I'm going to draw it right here. Here's E, here's I, the centroid is J. And they're saying EJ is 11x minus 6, and JI is 30. And they're wanting to know what is X and what is EJ. So EJ, remember, our final amount's going to be using this information. Okay, so remember that we said that the smaller portion of the median is half of the larger portion. So if we take 2 of the smaller portions, it will equal 1 of the bigger portions. So let's go ahead and solve for X. X equals 6. What does EJ equal? 66 minus 6, so 60. Okay, let's see if there's any more that look good. Let's try this last one. Okay, so here, let's do this one. It's saying DC is 6x, DC, the whole thing. All right, DC is 6x. GC from the centroid on is 3x plus 7. And then we've got the smaller portion here, D. Alrighty, so what do we need to know? We want to know what X is, and then we want to know what GC is. How are we going to find out X? Well, we know that, if we divide up our 6x into thirds, we would have basically 2x for this small portion, 2x for this small portion, 2x for this small portion. We divide 6x divided by 3. Each little segment's 2x. So really you can put this whole smaller portion equal to 4x's because it's 2 of these segments, okay? So let's do that, and we're going to have 7 equal to 1x. So x is 7. How much is GC? 28. For our final section of this video, in this lesson, is we're going to talk about altitudes. And altitudes, when they intersect at the orthocenter. So remember that an altitude starts at the vertex, goes to the opposite side at a right angle, so it joins the vertex to the opposite side, so that is perpendicular to that side. Altitudes can be inside the triangle, outside a triangle, or the side of the triangle. So in this case, this is the one we just did up above. This is inside. It can also be from this vertex to the opposite side, just like when you're doing base and height for area. It's right there. That's the altitude. Or it can be just the straight side right there. That's the altitude. Alrighty, so let's look at the orthocenter information. When 3 altitudes intersect in a triangle, they intersect at the orthocenter. And so let's list the altitudes here. One is BF. One is AE. And one is CD. How do we know these are altitudes? Because they're starting at the vertex, they're making a right angle right there. They're giving us that it's perpendicular, and there's no congruency marks. So so that's how we can know. You would look for the the right angle segment joining the vertex of the other side. Name the name of the orthocenter. It's P. And that's it for this portion. Now there's going to be a review. So let's see if we can remember all these. Now for my class, and I'll teach y'all too if you want to know it, we just made up a silly thing and we said that AI created our meal. And what is our meal? Our meal is peanut butter Captain Crunch, mac and cheese, and apples and oranges. And that's kind of how we remembered which one went with which one. So the one that goes with circumcenter is this one, the CC. So peanut butter. Perpendicular, when three perpendicular bisectors of the sides of a triangle intersect at the circumcenter. The incenter is this one. Starts with an A, angle bisector. When three angle bisectors of the angles of a triangle intersect at the incenter. All right, now centroid goes with this one, mac and cheese. That is median. Three medians of a triangle intersect at the centroid. Now we have orthocenter, that's the apples and oranges. That's altitude, the one we just learned. Altitudes of a triangle intersect at the orthocenter. All right, then these were two things we learned about some of these. So what is it that's equidistant from the vertices of the triangle? So we learned that one on Monday. Well, I'm not going to draw a picture for you. Let me just give you the answers to these. A circumcenter. And remember, that's created by perpendicular bisectors. So it's a ray that makes two congruent segments. When those are equidistant from the vertices when you have a circumcenter. And the second one is the incenter is equidistant from the sides of the triangle.